So welcome to the next episode of my video series about Linux. In this video, we'll try to learn about the basics of shell scripting and defining variables. So stick with me to find out more about this. Hello and what's up guys, Medium Guy here. I hope you're enjoying my video series about Linux. I'd be really glad if you have any ideas, if you have any comments, just go ahead and leave it in the comments section down below. And in this video we'll see about the basics of shell scripting, what it is, and we'll start to play with it. So if you are interested, just let's get down to work. So basically a shell script is nothing but a sequence of commands that are executed one by one, and also it can have some variables that store some data in them. Also we can have arguments that are passed to it, and using the conditional statements we decide about these arguments values, and we do some different commands according to the values that are passed to the currently running shell script. So let's see this in action. So I'll start off by creating a very simple bash script file, so you get a total idea about what a bash script is. So I'll leave all the files in my GitHub repository, which I'll put the links down below so you can access them very easily. So the first thing I'm going to say nano test.sh, and in here the first line of it basically is a comment pointing to the exact location of the bash executable. So I'll say /bin/bash. So basically in here I can write any bash script that I would simply write in the shell itself. So like for example, I'll say echo, and as the value I'll say hello from the bash script. So in order to save this file, I'll hit Ctrl X, Y, enter. So in order to run the bash script, I can do it in many ways. The first way, I'll just need to make this file executable. So I'll say chmod +x test.sh. If you don't know about changing the modifications, I have a video explaining all about this in this video series. So I'll put the link down below if you want to check it out. So the next thing I can say // and put in my executable file's name. So it is test.sh. If I hit enter, I'll see the exact same output that I wrote in the echo in the bash script, which was the echo hello from the bash script. So again, I'll try to nano the test.sh. In here, as I mentioned, we can have variables. So like for example, I'll say name equals to bash script, and in here I can simply refer to it by saying $name. So I'll save and exit the file. Again, I'll try to run the bash script. I'll be able to have the exact same output, but this time it is reading the value from the variable that I declared inside the bash script. So again, I'll go back to the test.sh file. In the bash script, we can have inputs which would read from the input that the user provides when the bash script asks for a input. So in order to access this, I'll say echo input your name, and this time instead of assigning a value to the name variable, I'll just remove the equal part, and in here I say read name, and I'll just go ahead and remove the from the output. So if I again save the file and run the test.sh file, in here it asks me for input your name. I'll just input some random words. So I'll for example say bash. It says hello bash. So as we see, in this way our name variable can have some dynamic values according to the user's input. So we have a read-only variable. So if I go edit the script file, In here, I'll remove the echo. I'll change the read to read only and pass the name to it. And I'll say name equals to bash. And after I set the name to a read-only variable, I'll try to change the value of the name by saying script. I'll hit save, and if I try to run it, it should throw the error saying that name is a read-only variable, and as we see, it has not changed the value that we set previously in the beginning of the bash script. So another command, we have the unset, which unsets a variable. So if I try to again nano the script file, so I'll try to remove the read-only name, and after I set a value to the name, I'll try to say unset name, and if I go ahead and run this, I'll see that the name variable has no longer a value. So this is how we unset the variables. So as we know, we have three different types of variables. One is the local variables that we saw so far in this video. Simply we just go ahead and define some variables and use their values when we need them. Next we have environment variables when we start a bash session. And next we have the shell variables, which are predefined by the shell itself, and it has their own uses. We're going to see exactly how we can use them. So I'll try to edit the file. The first variable, I'll say echo $$. If I hit save, I'll run the file. I'll see it returns a number, which is the PID of the child process that is created for running the bash script. So like for example, if I say echo $$ over here, which is not inside the bash script, I should see some different number, which is the PID for currently running bash session. So again, if I try to run the bash script again, I should be seeing some different PIDs because the previous child process has been created with a unique PID and it has executed and finished execution, and next time we try to run a bash script, it'll try to assign another unique PID. So I'll try to again nano the file. I'll say echo $0. If I try to run the bash script, I'll see that it echoed the bash script's name that is currently running. So basically, as we saw, the $0 refers to the file's name that has created a child process and running as a bash script. So next up we have $n, where n refers to a number which starts from 1, and each of them would refer to any argument that is passed to when running the bash script. So like for example, if I try to edit the file, in here I'll say echo $1, next I'll say echo $2, I'll save the file, and if I run the bash script, I'll see that I have some spaces over here because I didn't pass any argument when running the bash script. So like for example, if I say 1 and 2, I hit enter, and as I can see, the output of $1 and $2 is exactly the same things that I passed as arguments when running the bash script. So next up we have the $hashtag sign, which refers to the total number of the arguments that is passed for running the bash script. So if I say test.sh 1, 2, I should expect getting the number 2 as the output for the $hashtag sign. So I just changed the bash script a little bit for better viewing and understanding it. If I run it, I'll see that the current PID is a number, the file name, the first argument, second, and the total number of arguments that is passed for running the script. So next up we have the $*. So I'll say $*. I'll save, I'll try to run it, and as we can see, it returns only the arguments that are passed to when running the shell script. So next up we have the $? So I'll say echo $? Which returns the exit code for the last command that executed. So if I hit enter, it is 0, which stands for success, because when running the test sh12 we had no errors. The default and the success exit code is 0, so as we can see, the $? returned 0. So I'll try to edit the test.sh file. At the end I'll say exit 1, which tries to kill this execution of this bash script with status code of 1. So I'll save, I'll run the bash script again, and if I try to access the value of $? I should be seeing 1 as the output, so it is not 0. Basically, if we have any errors in our bash script or any command that we're running, the value of the $? will not be 0, and it will be the exact code for the relevant error that we had when executing the last command. So with that, that's all for this video. We'll try to continue our bash scripting story in the next videos, so I'll be glad if you also join me in them. If you have any questions, just go ahead and ask me in the comments section down below. I'll put all the relevant links down below so you can access them easily. Don't forget to like and subscribe, and with that, I hope to see you in the next videos.